Hello learners, in this video we are going to learn how to run one-way ANOVA in SPSS. So very basic question comes that why we need to run one-way ANOVA. So when we are trying to compare mean of one continuous dependent variable across three or more independent categorical groups, we need to go with one-way ANOVA. So let's take one caselet and make this statement more clearer. Uh, Bholu wants to know if the layout of his bakery affects customer spending or not. He randomly assigns 24 customers to the shop under three conditions, where layout A is a traditional glass counter, layout B is self-service island, and layout C is open buffet style. So he is trying to select random 25 samples and want to know whether the spending of the customers differ or not. So you can see this variable is a numerical continuous variable, and this variable, that is a kind of categorical variable, which makes a category of 8 customer who is in glass counter, the second 8 customer who is in a self service, and the third who is an open buffet. So here you have one categorical variable which makes 3 category and one continuous variable. So let's make hypothesis. So in this, the null hypothesis would be population mu is equal to population mu 2 is equal to population mu 3. In other words, the spending in layout 1 or layout A is equal to spending in layout B is equal to spending in layout C. Whereas alternate would say any one of the population mean differs. So let's run a test in SPSS. So I am loading the data. Just click open. Just click to Excel. Select the file. Select the sheet. OK. So you can see my data is loaded. So my first 8 customer is of glass layout. Second would be self-service and third would be open buffet. So I will just rename the variable. So I am just clicking this C here. In layout, bakery layout, here I will just click on values. I will click 1, that is glass layout counter. The second is self-service. So I will click here. Again here will give 2. I will click OK. And here the third one is open buffet. So here I am just clicking again. So here I have just given label. If you want to check, you can see here this would be transforming as I click this label, value labels. Okay, very simple first step. Always remember, one-way ANOVA is parametric test, or in other words mean based test. So we need to check the normality. So for checking normality, the same step, click on analyze, click on descriptive statistics, click on explore. Yes, you need to check normality of this spend amount. Just click on plots, activate normality with plots. Just click OK. Just click OK. So you can see this tab where Sapiro-Wilk and Simro KS test is there. So here you need to see the p-value. If p-value is more than 0.05, we can say the data is normally distributed. So here, yes, KS test and Sapiro-Wilk test both have p-value more than 0.05. So we can say this data is normally distributed and we can go with one-way ANOVA. Now click on Analyze, click on Compare Mean, click on one-way ANOVA. So here your dependent list would be spent amount and your factor would be bakery layout. Just hit OK. So you can see here your one-way ANOVA is giving this tab. Here you need to see this value, the p value. So here p value is less than 0.05. So just check our hypothesis. So our hypothesis where population mean of A is equal to population mean of B is equal to population mean of 3. And that is my null hypothesis. Alternate states that any one of it is differ. So p value is less than 0.05. So we reject the null hypothesis. So when we reject the null hypothesis, it is a clear-cut answer that we have to go with alternate hypothesis, means the spending amount, the mean spending amount is different. Maybe of any one category or all the three can be different. So now I want to know which category is better. So I will just click again analyze. I will click on compare mean. I will click on one-way ANOVA. All the things are set, but here I will click on Post-Hoc and I will just activate this Tukey. I will just click OK. So you can see this here, all the p value. You can see pairwise comparison is done. That is B and C, layout B and C. So here pairwise comparison is done and here p value is given. So let's see the hypothesis, what the hypothesis states of this. So here the hypothesis states that there is no difference in mean spend between two layouts. So for example, B and C layout gives same. So here you can see the p-value is rejecting the null hypothesis. So it says that there is a difference and that difference is here. The mean difference is here. Same way the mean difference of other two categories is also here. And same way the three other. Now if you want to know which is the better, suppose you are owner, you need to take the judgment which category is better or which layout gives better output. So you can see here the spending is given. So suppose if you go with glass counter, your spending of mean spending would be 160. If you go with self-service, it would be 290, and you go with open buffet, it would be 427. So as a owner, you can see the beneficial of the bakery and you can have a open buffet. So this would be your implication. So this way we need to run one-way ANOVA. Thank you.